Aaron here, and in this video I'm going to be talking to you guys about Hamming code. So in this case we're going to show you a quick way to kind of get a code that's written in Hamming code and quickly know how to fix it. So first of all, this is the code we're given. It's 0, 0, 1, 1, 0, 1, and 1. The first thing I'm going to do is I'm going to write off the number of boxes starting from left to right. So we're going to do 1, 2, 3, 4, 5, 6, 7. And as we can see, this is a 7-bit code. Next thing I'm going to do is I'm going to just go ahead and circle the numbers that are powers of 2. So we have 1, 2, and 4. If this was a longer code, by the way, I would go ahead and circle the 8, the 16, the 32, etc. But for this example, we're just going to circle 1, 2, and 4. The next thing that's very important to do is we're going to write down the following numbers. Now, these numbers you do have to remember. So I would go ahead and do that. So 1, 3, 5, and 7, that's pretty easy to remember those numbers. Then we have numbers that are a little bit harder to remember. So they're 2, 3, 6, and 7. So those are a little bit harder to remember. The next set of numbers are relatively easy. They start from 4, 5, 6, and 7. Okay, so as we can see, the first of each of those set of numbers are powers of 2. So that's going to help us out right here. So we have our code in Hamming code, and the first thing I'm going to do is I'm going to look at our 1, 3, 5, and 7. So before we actually do that, I want to tell you something, that the code that's written in Hamming is going to be in all the boxes of numbers that are not in the powers of 2. So for instance, this code would be 1, 0, 1, and 1. Okay, we ignore these numbers, the ones that are in powers of 2, and this is what our original code would be. So that's very important to remember. Okay, now what we're going to do is we're going to actually look at 1, 3, 5, and 7. So I'm going to I'm just going to write all these numbers that are in the boxes 1, 3, 5, and 7. So 1, 3, 5, and 7. I just pulled these numbers out. And what we're looking at is we're looking to see if there's an even amount of ones. Okay, so if there are an even amount of ones here, which there are not, there are 3 ones. So we're going to put a red X under that box. Okay, so we put a red box there, a red X. We're going to use that very soon. All right, the next number we're going to look at is the 2, 3, 6, and 7. So hang on just a second. So let's look at 2, 3, 6, and 7. So I'm just going to bring these numbers out. So 0, 1, 1, and 7. And here we have the same thing. The same thing went on. Our priority bit, which is this 2, is wrong because there are an odd amount of 1s. So we're going to put an X under that as well. I'm just going to erase the rest here. Now, the next thing we're going to do is we're going to be looking at our 4, 5, 6, and 7 line. So let's go ahead and bring out all of those numbers. So this is 1, 0, 1, and 1. So now as we can see, in this box as well, we have some problems. Okay, we can see that our priority bit is off because there are an odd amount of 1. So what we're going to do is we are going to go ahead and put an X on that 4 as well. So now what do? We have 3 X's. All our priority bits are wrong. Now what we're going to do is a simple math calculation. 1 plus 2 plus 4. Okay, because we have X's under all our bad priority bits. So we're going to calculate 1 plus 2 plus 4. And that is going to be 7. So now what is this 7? This 7 over here tells us that we have a problem in our 7th bit. Okay, and what does it mean when we have a problem? Well, we just know that instead of a 1 here, it needs to be a 0. So I'm going to cross that out. I'm going to write here 0. Okay, that was one example of using Hamming codes with 7-bit. This example was quite complicated, not that complicated, just for the reason that all the priority bits were wrong. If one of them was right, then I would have just put a check here, and then let's say if the 401 bit was right, then I just would have calculated 1 plus 2, that would be 3, and then this bit over here I would have needed to change. But in this case, all the priority bits were incorrect, so we knew to count 1, 2, and 4, and that equals 7, and to change the 7th bit. Thank you very much for watching. If you enjoyed this video or have any questions, feel free to leave a comment down below. Subscribe and have a great rest of your day.